So imagine you're in space, and as you know, in space, there's a lot of runaway objects like black holes. I'm gonna draw one here, and it has a singularity at its center and a lot of gravity. So if it has a lot of gravity, objects with other mass are gonna orbit it, like asteroids. Let's say asteroids orbit it in a counterclockwise direction, like that. And if we were to put this on a 2D vector field, then it would look like this. Here's the y-axis. Here's the x-axis. And counterclockwise. This is the black hole right here at the vortex. Counterclockwise. And here are the vectors, some with different magnitudes, but all pretty much counterclockwise in the same direction. And as you can see, it's going in a circle. And the name for this is called curl, C-U-R-L. And let's say to find the value absolute value of curl, you need to find the vector function for the vector field first. And let's say that's going to be f. See, that was the vector function. Yeah, f is the x component is 3x plus y, and the y component is sine of y. And the formula for 2D curl is partial fy over partial x, or partial x, and minus partial fx over partial y, where fx and fy are the y components and the x components. And these are partial derivatives, partial differentials. That is equal to curl of f. Well, this little thingy, that's nabla, and that is the cross product. That is the curl operator. That's where we find the value of the curl of, but it can't be used on a scalar. It can only be used on a vector function. So it can't be, you can't find this. It's not, you can't find the curl of 3. Because 3 is a scalar. You can only find the curl of something like this. And to find the curl, let's do an example with f. And so since we know fy is sine of y, partial fy over partial x. But we know we treat, in partial derivatives, we treat if it's a multivariable function, and if it's a single variable function, then the only thing we do is just take the normal derivative. So since this is a one variable function, and the derivative with respect to x, and it's only with y, then this just crosses out to 0. 0. And so it's just negative partial fx over partial y for now. And fx is 3x plus y over partial y. Well, partial fx over partial y would be equal to partial over partial y of 3x plus y which should be equal to d over dx. So when you take partial derivatives, like I said in my last video, you treat the other remaining variable like a constant. So 3c, which well, C is any constant. A constant, which 3 multiplied by another constant is just going to be a constant. So C plus Y equals, C goes to 0 because the derivative of a constant is 0. If the derivative of a constant is 0. Oh wait, sorry, I'm so sorry. I was taking d over dx. So it was supposed to be d over dy. So d over dy. So that's gonna be y, because 0 plus y. So the actual curl of f is just gonna be y. So if we had, so finding the over, it's not a big y. So if we had the overall curl of the vector function, we're gonna take it at the vortex. Since the vortex is the black hole, and the black hole is the center of gravity in our scenario. And plugging it in, we have the vortex is equal to 0.00, and y, this is x and this is y. So y is equal to 0. So, but why is it equal to 0? Well, that's because I didn't actually, that shows that this vector function isn't actually representing this vector field. So now we know. Does this one have divergence though? Well, it could have, so it doesn't have an overall of the whole vector field, but it might have it at one specific point. Like at point 3, let's say at point P, 3, 2, this is y and this is x, so it's gonna have a curl of 2. Yep. Curl operators. Don't forget those. And so as the y increases, the curl is also gonna increase. And if x increases or decreases, it doesn't matter, because the curl of f is only dependent on y in this scenario. So if p was 0, infinity, this is x and this is y, so the curl is going to be equal to infinity. And over here we have the 2D, but we have the 2D version of a curl. But what if we wanted to go 3D? We need another paper for this because this is a long equation. So this is going to be equal to, I forgot. Well, how will I cope with my rapidly declining memory? Well, I can just find the determinant of this. I could just find this. X, Y, Z. Well, these are unit vectors. Partial over partial X. Partial over partial Y. Partial over partial Z. Well, these are partial differentials. And P, Q, and O. Well, they are they're used in this determinant. I don't know why, but they represent Fx, Fy, and Fz. Now, if we wanted to find the determinant of this, we could just do copy the first 2 rows. And then we could multiply down, and finding the determinant would get us to multiply down right here. Partial f, z, over partial y, x hat to show it's a unit vector. So let's do these, because that means they're unit vectors and they have a magnitude of 1. It doesn't change the value of a term. And plus, we multiply down again. P is f. Oh, so yeah, no. partial fx over partial y hat plus partial fy over, because we multiply down right here, and we also multiply down right here. Partial fy over partial z y hat, and then subtract and multiply. So we have multiply up this time. Partial fx over partial fx over partial y, and we have partial y z hat, and multiplying up we have minus, or we could put the parentheses here and then put the plus, but let's just do the minus for now. Minus partial fy over partial z x hat minus, so we know there's going to be y hat because there's nothing left. What is it? Yeah, it is y hat. Partial fz over partial x, and then we have y hat. That is your formula for cool if it's 3D, but should I use an example?
Sure. Just so you know, you're at 12 minutes, but you could keep going.
I'm going to get a different pencil because this pencil is really dull.
Okay.
Let's say we have a 3D one. It's going to be f of x, y, z to show it's 3D. It's equal to let's do the same x and y components as last time. X and y components are three x plus y sine y. We need one with z. Let's do tangent. Not tangent, no, that wouldn't be a very good outcome. That would be with all messy fraction. Z squared plus xy. So we have a formula right here, and it is partial fz over partial y x hat. We don't have to write these x hats if you don't want, or y hats or z hats, because they don't change the value of the term. They just show the direction that they're going in. So it's not to not confuse us. Partial fx over partial y plus partial fy over partial z. Wait. I'm sorry, guys. It was supposed to be... It wasn't supposed to be y right there. It was supposed to be z. And this was supposed to be x. Gonna still round. Minus partial fx over partial y. Z hat. I don't have to write the z hat, do I? Minus partial fy over partial z. Minus partial fz over partial y. And that is it. Equals And we just take the derivatives of these, and we'll get take this, and it's going to be, this goes to 0 since it's a constant. C, the derivative of cy is just going to be c, which is x in this case. It's going to be x plus partial z of 3x plus y, 0. All goes to a constant because it's not dependent on z at all. Plus partial x of sine of y. Again, 0. It's not dependent on x. Plus partial over partial y. 3x plus y. Now this is not going to go to 0 because it's dependent on y in some way. And this is going to go to a constant, so it's just going to be equal to y. Because constant goes to 0. 3 times any constant is 0. It's going to go to y, so our final one is x plus y. Partial z of fy. That goes to 0 because fy is sine of y not dependent on z. It just goes to a constant. Sine of a constant is just a constant. 0. And then we have partial of z over partial y. That's minus y, not plus y. Was it plus? Yeah, it was plus y, sorry. Okay, that's x plus y. And then partial over partial y. Fz is z squared plus xy. Well, this goes to 0 since it's nothing else really. And this right here goes to a constant. So cy is going to be x, so 2x plus y.
You're at 17 and a half minutes.
Right. So this is 2x plus y. So let's say if it was at 0, 2 times 0 is 0, plus 0 is 0. So again, for this vector function, overall it's going to be 0. But if we had point, let's say 3, 2, it needs a z component, doesn't it? 3, 2, 5, it's going to be 2x plus y. This isn't dependent on z, so whatever. 2x is 2 times 3 is 6. 6 plus y is 2, which is 8. So at that point it's going to be 8. And if we have 5, 3, and then I'm just going to put z from now on since it's arbitrary and we don't really need it since this is not dependent on y. On z. We have 13. And so on.
All set?